Well, hello everyone. Welcome to our next installment of math videos. I made that up. I don't know if that's what this is really called, but it sounded good, or did it? Anyway, today we are talking about multiplication and arrays. So we just kind of want to like break apart like what does that mean? What are we looking at? What's our jam? Right? What's happening here? So what it means to multiply and like how we do it, modeling, I guess. I shouldn't even say showing, I should say modeling with arrays. So a couple things to break down. Again, just a quick reminder, an array is built up of rows, so the things that goes left and right, and columns, those are the things that go up and down. And then like another term that I'll probably be using just so we're aware of vocabulary is product, and that's the answer to a multiplication problem. So if I'm like, what's the product of 2 and 4? That just means 2 times 4, and then the answer. So that which would be 8. So the product is 8. So that's what we have in store for today. So let's go ahead and get started and play around, right? So multiplication as an array. So I'm going to go ahead and start. I don't know, let's just randomly pick a number of 3 times 6. So that's our first problem. That's right. It is a multiplication problem here, 3 times 6. I guess before actually I even get further, I want you to know that we also use these multiplication symbols interchangeably. So there's kind of 3 ways we can show the symbol. We can use the X, we can use the dot, and we can use the star. All of these say multiplication, so just keep that in mind. All right, so an array. As I said before, an array is a model that shows how we can organize things in rows, meaning left, whoa, haha, which is left and right, and columns, which is up and down. And that's all this multiplication sentence really says. It talks about this idea of, and it's interchangeable, like you can say rows or columns first, it's up to you. And we'll talk more in class about why, but this to me is just saying, for example, I have 3 rows and in each row is 6. So if I had to do 3 rows, I could be like 1, 2, 3, right? I have 3 rows. And then each row has 6. So there's 1, 2, 3, 4, 5, 6. And what makes an array work is that everything is lined up in these rows and columns like evenly. So you can see like each dot is kind of set up with each dot. So there we have it, right? Here would be my 3, the 3 rows. And then like I said, there's 6 in each row. And if we look at that, that actually also shows that there's 6 columns. Sorry, columns are right on top of you. And you can see that there's 1, 2, 3, 4, 5, 6. So this is like what an array is. It shows these rows and columns all lined up. And if I really just wanted to know, well, what is the answer to 3 times 6, right? Well, that's 3 rows of 6 or 6 columns of 3. You can look at it either way, and I could just count. I could like skip count, I guess. Let's do like 3, 6, 9, 12, 15, 18. I just counted by 3s. And there you have it, 3 times 6. So this is kind of what we're doing, and we want to be able to model these arrays to represent a multiplication problem. So that's kind of where we're at. So let's play with that a little more. So let's see. I'm going to do this one again real quick. So again, it doesn't, it just kind of shows up. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, lining up. And you can almost, and you can see, I was going to say almost, but you can see it just really makes a rectangle. And so sometimes arrays make rectangles and sometimes they make squares. So that's one thing to keep in mind. So that's cool. All right, so let's look at another one. Let's think about this idea of 4 times 2. Okay, so again, we might already know the answer to that, but our skill today is like, how do we represent this as an array? So it's interchangeable again. So I could do my first number as rows, or I could do my first number as columns. It doesn't matter. Let's just, for the sake of mixing it up, I'll start with 4 and make it my columns. So that means I have 4 columns. So 1, 2, 3, 4. And then in each column, there's 2. So there's already 1 written. So 1, 2, 1, 2, 1, 2, 1, 2. So then I could again look at this, right? Whoa. So there's 4 going across here. And then there's 2 going across here. So 4 times 2 equals, well, we can just skip count again. 2, 4, 6, 8. So 4 times 2 is equal to 8. Okay, so again, that's what I'm putting out there is all this circles and stuff, but really at the end of the day, the array just looks like this, right? The array would just be 1, 2, 3, 4 with 2 in each. That's my array right here. Okay, now with all the circles and the squigglies, I'm just modeling. Okay, so great, awesome. There we go. Arrays, multiplication problems. Now, where we're going to take this to is like really kind of what starts to happen as these numbers get larger and how we can build that up and how we can show that in an array. So let's say, right, here, let's do it. I'll rewrite this one again so it's clean. So this time I'll go with 4 rows and 2 in each. And as you can see, it's the same array. It's just like moved, right? Okay. And that equals 8 because there are 8 total dots. But like what happens as we get larger, right? Like what happens as we start to think about, well, okay, let's say I still have 4, but I'm multiplying it by 20. Like how do we start to model this? And that's really what today's skill is all about. So again, I'm going to think about another way I can model this array to help me. And what I'm going to do is I'm going to think about what I know. Like I know there's 4 ones, right? I'm going to use base 10 to model this. So I'm just going to go with 1, 2, 3, 4 ones, right? Again, because I don't know, 4 rows. And this time in each row, there's 20. Now, instead of like going like 1, 2, 3, 4, 5, 6, 7, 8, you know, and counting on forever, what I can do is erase that. What I can do is think about, and I like to actually start to then build another model, like another frame to kind of help me. So I'm going to go like this, like here's a bit of a frame. And I think about, oh, well, I can show 20 as 2 10s. There's 1 10, 2 10s, right? 10, 20. Again, if you're not sure where I'm getting that line from, I'm just really thinking about like 10 dots put together to make a long or a stick, right? So this is a 10. And I'm putting it sideways so it's easier to see. So if we think about that then, right, this is just to help me organize this work, I could actually model what that is, because if this is 1 and there's 10, whoa, rewind, sorry, I don't know how that got erased. If this is 1 and there's 10 here, so that would be like 1 times 10 is 10, 20, 30, 40. Right, and then the same thing. I'm kind of looking in these rows and columns. So this is this 1 here times this 10 here. So 10, 20, 30, 40. And I could just count those up, right? So I said this 10, 20, 30, 40 plus another 40. So that actually equals 80. And if you look at really what's happening, we can start to think about these patterns. Right. Oh, wait, what's happening here? Oh, I had 8, now I have 80. Somehow it got 10 times greater. Oh, I wonder if that's because my 2 also got 10 times greater. So maybe I can start to see a pattern. Hint, hint, haha. But again, let's go back to helping us model this. So let's do another one because 1 is never enough. So I don't know, 4 times 3? No, let's do 4 times 5. 4 times 5, great. Okay, so again, we're going to model this as an array. So I'm going to go 1, 2, 3, 4 rows, and then 5 columns. So 1, 2, 3, 4, 5. And then I can fill it all in. I don't have to count each one. I just have to make sure they're lined up, and I know I'll have my array. And actually, to help me even solve this, if you think about it, there's 5 in each row. So I could just skip count 5, 10, 15, 20. So that equals 20. Okay. Now, let's take it to that next level of like what happens if you start getting larger numbers. And let's say that this time, instead of 4, we have 40. And we're going to multiply that by 5. Okay, now if you think about what happened last time, I just got 10 times greater with one of my numbers. So we can already assume my answer is going to be 10 times greater. But let's prove that by modeling. Okay, so what we see here is I have 40, right? So if I model 40, I could just say, I could do that as tens. So I could say, let's make that columns. I could say 10, 20, 30, 40. And I'm going to use a little graphic organizer. I'm not going to quite line it up like that. I'm just going to go like here. It's like a little graphic organizer. And then we need 5 ones, right? Because these are ones, and that's the rows. So 1, 2, 3, 4, 5. Okay, so now if we just think about what that means, right? If I have 1, 10, that's a 10 there. And here's another one. There's another 10, 10, right? Do you see where I'm getting that? I'm gonna try to show that. I'm really just thinking about this 10 and this 1, and where they meet is right there. That's one group of 10, 1 times 10. So that's where that's coming from. So let's see, I'm gonna get rid of that now. Hope that helped. Okay, so let's see, where were we? So we got 10, 20, 30, 40, 50. Okay, and then this row, or column, excuse me, 10, 20, 30, 40, 50. 10, 20, 30, 40, and 50. And 10, 20, 30, 40, and 50. And then if I just add all these up, well, this is doubles facts. 50 plus 50 is 100. 50 plus 50 is 100. 100 plus 100 equals 200. And what do you know, right? Remember when I said hint, hint, hey, hey, look over here, right? This digit got 10 times greater. So our answer actually got 10 times greater. But again, that's how we can model that. Okay, so let's just do one more. I'm gonna squeeze one more in. We're kind of running out of time here, but I'm gonna do it. I'm gonna do it anyway. What if we had 3 and we had to multiply that by 70? Okay, so again, let's do a quick model of what that would look like. I'm gonna go ahead and now I'm gonna build that little graphic organizer first. This helps me organize my work. And then I'm gonna go with 70. So 10, 20, 30, 40, 50, 60, 70. Oh, that got sloppy. I don't like that, but hey, for the sake of time, let's just extend this out. And then I have 3 ones. So, oops. Okay, sorry. I'm like trying to go so fast. I keep making mistakes. 1, 2, 3. Okay, so this would be 10, 20, 30. 10, 20, 30. I guess I should be writing these down as I go. 10, 20, 30. 10, 20, 30. They're just groups of 30. And it looks like I'm gonna have 7 of them, which I guess that's literally what this says, right? 10, 20, 30, and 10. Sorry, that's sloppy. I apologize for squeezing that in. That's not cool. I'm not into that. All right, well, let's add all this together. So that makes a 60 plus another 60 plus another 60. And then we have plus 30. So let's see, 60 and 60 is 120. 60 and 30 is 90. So 120 plus 90. Let's see, if I put 80 here, that makes 200. I took the 80 from this 90, leaving only 10. So now 10 plus 200 would be 210. So there you have it. This is the kind of work that we're doing. So let's work on it the best we can. Let's model it. Let's see what we can do. Let's try to make sense of it. This is a building block to some other steps. So thank you for your time, and we will see you soon.